Hello and welcome to Teammates' interim presentation on the analysis and redesign of a Luxo desk lamp. Our group is comprised of Jorge, Chris, Robert, Anthony, Michael, and Ethan. Desk lamps are used to supplement workspace lighting and provide additional illumination for visibility. Our primary customer group are businesses who purchase desk lamps for office space and standard desks. The secondary customer group we are targeting are individuals who purchase desk lamps for home use. In the exploded assembly, we see that we have 31 different components with 19 different part numbers. In the subassembly view, we have a bottom arm, middle joint, top arm, and lamp subassembly.
For our functional analysis, we determined the main functions of the lamp to be lighting objects, with subfunctions of directing light and providing light, each with their own respective subfunctions. To assure dependability of the lamp, we determined that it needs to prevent overheating, and in order to enhance the product, we determined that we needed to control its brightness, adjust its height, and adjust its angle.
The first sequence builds by starting with the lamp base, then building from the bottom arm to the middle joint to the upper arm and the light, while attaching each of the subassemblies in that order when they are built. This process will look something like this CAD model being built in this slide. We chose this assembly sequence because building from the base first seems logical, since it's the largest and sturdiest component to the lamp. The second assembly method focuses on building the lamp arm first from its subassemblies, then moving on to the base and the light. As you can see, the building order goes from the middle joint to the top arm to the bottom arm to build the lamp arm, then finishing with the base and the light. This process is better pictured being built here. We chose this method because it makes the most complex part first, then finishes attaching the large basic parts after. When comparing these two methods, the main differences come from the ease of transferring, the testing of subassemblies, and the ease of parallel assembly. Because the base up method includes the bulky base first, it makes it harder to move and transfer parts as well as assemble in parallel. Not only that, but since the building from the base up requires the base to be involved in testing each subassembly, it makes testing each subassembly much more difficult than expected without interference from the base.
This is our bill of materials shown here. We took all the components from the exploded assembly view on slide 3 and we put them here. This let us make a couple of assumptions. The first is that the lamp bulb accounts for all the electronics in the lamp because that's the way it is in the model. Second, we used all of the dimensions from our CAD model in material cost estimations, except for the springs and the lamps because we would just purchase those. We assumed $15 an hour as a working wage, and we would be producing 10,000 units. Because of the awkward shapes of a lot of the links, we think they are die casted. They'd be very difficult to machine, and we assumed all the pins were machined, although some of them also have some strange dimensions. This led us to a grand total of $14.61 per lamp, which we think is pretty accurate because online a similarly styled lamp goes for around $30, give or take, and wholesale of that would be somewhere around 50 to 70%, which brings us down to 16-ish, and our 1461 is below that.
All right, next up is the function component mapping matrix. Now, I'm not going to spend a lot of time going over this chart in detail, but basically we used the information from this chart and we used the bill of materials from the previous slide to determine 3 primary methods for redesign. The first involves changing the material of the most expensive parts, which are the lamp base and the lampshade cover, from aluminum to plastic. This would allow for cheaper material costs and the possibility of injection molding, which would also help to reduce the price. The second redesign involves reducing the number of parts in order to decrease the cost. This is a good option, especially since there's a lot of room for consolidation with this design. And the final redesign involves changing the geometry of the links to eliminate some of the machining. For example, having stock dimensions would help to reduce the cost significantly.
For the product family design, we have a table where we split our functions into 2 different categories. Those 2 categories are which functions are the same for both customers and which functions would be different for each customer. As you can see, how the weight is supported and distributed will stay the same for both variations. How the power, airflow, and brightness is handled will also remain the same for both product variations. The main difference between the variations for primary and secondary customers is the adjustability. We plan to have the primary design allow adjustability in height and angle, while the secondary design has no real adjustability.
Continuing with product family design, we split up the different components of the lamp into two categories: platforms, which would be the same across customer groups, and modules, which would be different across customer groups. Under modules, we included everything that comprises the arm itself, whereas under platforms, we included the lamp base, shade cover, bulb, and neck. Below, you can see our designs for primary and secondary customer groups. The design for primary customer groups utilizes a linkage similar to the original design. For this design, we cut down on the number of arms of the linkage to reduce overall cost while maintaining the ability to adjust height and angle. We additionally replaced the pins with nuts and bolts. For the secondary customer group design, we changed the arm entirely to a rod to completely simplify the product. And additionally, we connected it to the lamp itself with a linkage and screws. This maintains its functionality while overall reducing its cost.